as kind of the prelude, we live in a special time. We're right in the middle of this graph right now. Instantaneous communication is a short-lived phenomenon for a technological civilization of sufficient longevity. All right, so online, offline equivalence, what our interplanetary tomorrow can teach us about building apps today. Before we get into it, a little bit about me, even though you've already heard a little bit about me. My name is Chad Ostrowski. I live in the Orion arm of the Milky Way galaxy, around a G-type main sequence star, on a water planet called Earth in a little city called Lancaster, Pennsylvania. I work at Citrusbyte. We're always looking for React people, so send us an application if you are into doing cool things with React. You can find me online in these places. And a disclaimer. We are all voyaging together. I am Cosmic Algae. I don't know everything about this topic. I'm pretty new to it myself, but I'm excited about it. So if I leave out your favorite technology related to all of this, please tell me about it. I want to know that stuff so that I can make this presentation more awesome next time I do it. All right. How far is it to Mars? Let's go over here. How? There we go. If Earth were 100 pixels wide, we're going to the moon now. The moon's pretty close. The moon would be 3,000 pixels away. Mars, at its closest, this one will take a little while. Note that the stars are moving. If you were really traveling there, there would be no stars moving. We're currently traveling 3 times faster than the speed of light, so we'll get to Mars in about a minute. Yeah, here we go. At the current state of space technology, it will take at least 150 days to get to Mars. The 2030s is when we're thinking we'll actually send some humans to Mars. 2033, maybe. Yeah, Elon this week said 2023, apparently. So if his crazy ambitious plan succeeds, maybe that'll happen. All right, so that is really far. 56 million kilometers, which divided by 300,000 kilometers per second, that is 3 light minutes away. At the closest. How many people have heard of MarsOne? All right, so MarsOne wanted to, they're still around. They still think that they're going to send people to Mars by the 2020s. A lot of experts think that they probably won't succeed, but they want to send 4 people who will live the rest of their lives there, 4 people who will permanently migrate to Mars, and then 4 more people 2 years later, and so on and so forth. Something MarsOne said in their FAQ that stuck with me. What will the astronauts do on Mars? And they say a bunch of other things that I didn't remember as well. But then this part, I was like, huh. Easy internet access will be limited to their preferred sites that are constantly updated on the local Mars web server. Other websites will take between 6 and 45 minutes to appear on their screen. First 3 to 22 for your click to reach Earth, and then another 3 to 22 for the website data to reach Mars. Contacting friends at home is possible by video, voice, or text message, email, WhatsApp, SMS, but real-time dialogue is not possible because of the time delay. 6-minute latency during the fast part of the year. Preferred sites that are constantly updated on the local Mars web server. And this makes me think, does this even qualify as the internet? What do you think? No, it doesn't qualify as the internet. The internet is a discussion. It's many to many. It's controlled by its participants. It is a great democratizer. And if I can't contribute, then it doesn't count. Let's think it through. Here's a simple app. It kind of is like a brochure app, right? This is a Patreon page. And down here in the bottom corner, we have a little like button, the ubiquitous like button. On Patreon, when you click the like button, it doesn't show up red that you like successfully clicked it until the request goes out to their server and back to your browser. So this page would work, but this would, when you click it, it would take 6 to 45 minutes for it to show up red. That's lame. Instagram would not be very Insta. If you and your fellow Martians are all posting photos, it would take them 45 minutes before they see what you actually posted. Apps like Google Docs that require a persistent connection across the backbone of the internet, that's just not possible at all. It'd be a little like this all the time. All right, so why do we care? Why do we care about this in 2016, right? These seem like maybe like we'll figure that out, who cares? 2016 has similar problems, and I also think if we manage to solve the Mars problem, right, we will solve a lot of really compelling problems right here on Earth right now. So this is where Amazon AWS data centers are located. If you are in sub-Saharan Africa, then when you make a request, it has to go the whole way up to Ireland and back before you see your content. So like out at the edge of, there are all these spots out at the edge of the network that are just really slow. And they're like crappy networks, right? So these people have really low-powered devices, and then we're trying to send them like these giant megabytes of just a regular page load, right? So this is a problem. And then you have, now and then, governments that just cut off internet access completely. And if we could figure out how to make the internet work on Mars, then we could figure out how to make it work between a bunch of computers or devices that protesters are using to organize where they're going to meet. And if that seems a little remote, remember that just a few months later, oh, right, that brings us back to these guys. This is the Arab Spring. So they want an internet that works on Mars. It would help them too. Just a few months after that, San Francisco shut down their internet for a little while due to protests. So this is something that happens right here. And then, of course, there are the more prosaic things like airplane mode or underground mode. Or even conference Wi-Fi, right? Like when people are at conferences, you all end up trying to you clog the network and no one can get to anything. And you have a whole bunch of perfectly good communication devices in your laps and no one can communicate. So offline is not an edge case, even in a connected world. What do we do about it? The first thing that comes to mind is offline first. Who here has heard of offline first? All right, a few people. It was written about on a list apart 3 years ago, so I guess it's about time for the rest of us to start picking it up. So what offline first doesn't mean is building apps assuming there will be constant fast connectivity, then adding in some graceful handling of inevitable network issues. That's called graceful degradation. It's analogous to designing for desktop and then only adding in some mobile support when people complain. What offline first champions is more like the mobile first movement. Don't treat lack of connectivity as an error condition. This is called progressive enhancement, of course. Assume that your users will be mostly, or at least frequently, offline, then progressively enhance your app to take advantage of network connectivity. All right, so I think a good example of graceful degradation and a counterexample to offline first is how Instagram works. If you've ever posted in airplane mode, it queues up your photo and doesn't actually post it. But it tells you it errored. That might be bad communication, right? It's really not an error. It's perfectly fine. When you're on the network again, you press this button and your photo goes up. It's actually really nice. But if you have crappy connection, you're not in airplane mode. You're just like, you had Wi-Fi on the train and now you've gone underground and you don't have Wi-Fi anymore. Then Instagram will just fail to upload your photo, it won't save your photo, and it might crash. So it's like, that's graceful degradation. Offline first would be always queue it up like this, right? Just save it to local memory, and then try to upload it from there. And if it fails, try again later, automatically for the user. All right, so the current web has a problem. The average web page is now the size of the original Doom game. I think it's, I forget what size that is. It's like 3.2 megabytes, I believe. For the people at the edge of the network, this really sucks. One thing we can do to get around it is service workers. Who here has heard of service workers? All right, cool. So this is an update to something that was called app cache. It is a better way of doing caching, and it can do other fun stuff too. As you can see, it's already in Chrome and Firefox. Microsoft Edge, it's already in development. Safari, it's under consideration. Safari, the new IE. Service workers basically work by intercepting all of the requests that a page makes, and it'll see if it has that resource. And if it has already cached that resource, then it automatically responds with that. So there's no round trip out across the backbone of the internet needed. It just sends what you already have on your device. If you're doing React, there are already people making libraries for you to use. There's the offline plugin. So you can add service workers pretty quickly to your existing React apps. People call this progressive web apps. Progressive web apps are web apps that feel like mobile apps, and having really quick assets is a big part of that. All right, so we've got the Martians, their assets. What about data? We've got a couple options for that. There's local storage, IndexedDB, Web SQL, some people may have heard of that. That has been deprecated, apparently. So that'll be phased out, and just IndexedDB and local storage are what's going to stick. There's a library called Local Forage that gives you a unified API for all of those. And of course, all of the browsers have implemented IndexedDB, Web SQL, and local storage very differently. Local Forage will make it easy to use all of those technologies. If you've gone through the building React applications with idiomatic Redux video series on egghead.io, Dan Abramov gives a really good, simple video. It's only 7.5 minutes on persisting your Redux state to local storage. And for simple apps, this totally works. For apps that don't need to resync with a database where all of the information lives right on the user's device, this can work really well. I recently went to a conference called Abstractions, and I built my own schedule explorer because theirs was really bad. And I did exactly what Dan Abramov showed there. And so this favorite thing, you refresh the page and it stays there. It obviously doesn't sync to your other devices. If you go and check it on your desktop, all your favorites aren't going to be there, but it's safe in your local one-device local storage. If you want to sync that information, PouchDB makes that really easy. So PouchDB is a front-end JavaScript implementation of a database called CouchDB. Couch with a K, no, with a C. And so it's basically just storing stuff in local storage again, and then making it very easy to sync that information to the backend database when the user has connectivity. This allows people to work offline very easily, but then also have access to the same information on other computers to maybe be able to share it with other people a little bit, and to be able to work on it on their phone and their computer. Hoodie is a whole like backend as a service that also makes it very easy to do offline first web development. I haven't played with it myself, but it seems like a pretty cool project. All right, So we've got one person's local data, but what about collaboration? We still haven't really solved the Google Docs on Mars problem. Oh, and of course, Google might be able to deploy their app to servers on Mars, so they would have that option. But there would be all kinds of apps, of course, that can't afford to do something like that. So how do we get people at the edge of the network able to collaborate, able to communicate on Twitter even when their government shuts down their internet? Everything we've talked about so far is still this client-server mentality, right? But we have these awesome, amazingly capable computers that are really good communication devices. Can we just get them to talk to each other instead of doing something like client to server? Our apps are addicted to the backbone. The networks we're using are so 20th century. We can do better. All right, so this is from a paper or a book written in like 1962, before, when was the internet invented? 1991. No, the web was 91. The DARPANET was like the late 60s. 69. 76 for most remote hosts. First remote host. Gotcha, gotcha. So in 62, people were thinking about like what kinds of networks they could build. And of course, you have a centralized network where everything has to go back to one central spot. And the DARPANET people were like, we don't want this because if someone bombs that one central spot, the whole network goes down, right? Like no one can communicate then because everything is mediated through one central spot. The internet today kind of works like the decentralized network, where we have lots of different nodes, right? So like this is one Google data center and that's another Google data center. And if this one goes down, if there's some natural disaster or whatever, then all of these people can still go get data from that one. But it's still it's not fully distributed, right? It's client to server. I want node to node. No client and server, just a whole bunch of nodes in in kind of a mesh network like that. This is my fancy catchphrase for the distributed web, where two or more devices are gathered. There the internet is. All right, so let's go into a history of kind of distributed web technology, because this stuff is really foundational to understanding new technologies that are emerging that are kind of building a distributed web that we can start building apps on today. 2001, BitTorrent was created. 2005, Git, and in 2009, Bitcoin. We'll go into these a little bit. This is from an article about, well, I'll get to what this article is about later, but BitTorrent, around since 2001, still very much alive despite concerted international billion-dollar efforts to destroy it. It's interesting to note that the BitTorrent community remains impossible to stop because it is both globally decentralized and continues to deliver data. That sounds really good for our protesters at the edge of the network with the governments that shut down the internet. All right, and Git, for all of you who used Git, you're used to this idea. Everyone's copy of something in Git is equivalent, right? Everyone has the same, like you could be the new source of truth. There's not a central server that everyone has to talk to. Everyone has all the data. That is in contrast to how older version management systems worked. Git, of course, is also versioned, right? Everything, it tracks all of the changes using those SHA-1 hashes. So every change points back to a previous change and says, I came from that. And finally, Bitcoin. Bitcoin works on the blockchain, and the blockchain is really confusing, but this is a simple explanation. So if I want to send money to Nikki, then the transaction is represented online as a block. The block is broadcast to everyone in the network. So the Bitcoin protocol says like, Chad wants to send this money, wants to send $5 to Nikki. And then everyone in the network works to verify that I actually have $5 to send to Nikki, that I haven't already sent that money to Alex. Once that is verified, the block can then be added to the chain, which provides an indelible and transparent record of transactions. And then the money moves from me to Nikki. And this brings us to IPFS. IPFS is a really cool new technology. You can see that they say they are the distributed web. A peer-to-peer hypermedia protocol to make the web faster, safer, and more open. Similar to the original aims of the web, but IPFS is actually more similar to a single BitTorrent swarm exchanging Git objects. What? All right. I like these definitions a little. I think they're more approachable. IPFS is a distributed file system that seeks to connect all computing devices with the same system of files. IPFS is becoming a new major subsystem of the internet. If built right, it could complement or replace HTTP. It could complement or replace even more. It sounds crazy. It is crazy. By the way, I don't know if I said IPFS stands for the interplanetary file system. Sounds like what I want. All right, something that IPFS does is it is content addressable. Let's look into what that means. Here I have a URL. It's for a specific tweet. If I want to read this tweet, I really only care about the content of the tweet. I don't care that it comes from twitter.com. But because of the way URLs work, this request is going to go out to Twitter's servers, and I have to specifically get this content from Twitter's servers. That would be a little bit like if I wanted to read a specific book and I had to go to one bookstore or library across the country or across the world. The way IPFS works is it's just kind of like a Git hash, right? And you obviously won't have to type this in. There are going to be URLs on top of this that are pretty. But it's just the content. This is a unique hash based on the contents of the document that you want. So if the document changes, the hash changes, and like Git, it's versioned. It goes all of the, so the entire web would actually, or anything in the IPFS network, would have an entire history of how it has changed across time and would be backed up on everyone who cares to offer some space for it in the network. IPFS likes to call itself the distributed web, sometimes also the permanent web, because all of these nodes in the network are backing up the data and all communicating it to each other. So this would be like if we're at a conference and and that conference Wi-Fi sucks, so we can't use Google Docs. If IPFS works, and a couple other technologies that we'll get into, we would still be able to collaborate on a document, just computer to computer. All of the or you would be able to get a video from my computer, similar to how BitTorrent is, where you're downloading little pieces from my computer and little pieces from someone else's computer. Everyone who has the video can help you download that faster. So you're downloading content right from people near you who already have it. And then you can help host it for other people, and other people can get it from you. I feel like the permanent web has, people get really excited about this, right? Like URLs won't die. You will always be able to get that content. That content will always exist. That's really cool. It's also like for online harassment and trolling and those kind of things, it worries me a little bit. I'd like to, I want to discuss that with the creators of IPFS, what their thoughts are on that. All right. So IPFS gives us distributed files. What about distributed data? Right? So now it's kind of analogous to where we were with just service workers. You have service workers, but you actually want to store data for the user. The user wants to be able to manipulate data, but now you want that data to be stored in a collaborative place. Once again, people are solving this issue. There is a database built on the blockchain called BigChainDB. I think there might be a couple other projects too that are similar. This is the one I found. And again, it's using that same blockchain technology to store data instead of like IPFS storing assets All right, so we've got distributed files and data, but if we wanted to build a fully distributed app that can kind of work out on any edge of the network, you need some kind of like server-side logic, but we got rid of our servers, right? Because like if you want to do a financial transaction, you need some way of doing that where you're not just trusting users to not manipulate their JavaScript or whatever. So really what we want is incorruptible logic. How do we get something that we can actually trust to make sure that users aren't cheating? This is where Ethereum comes in. Ethereum is similar to Bitcoin. It is a cryptocurrency, but it's specifically built so that you can have these smart contracts that run between all of the computers in the network, and everyone helps verify that that contract ran correctly. You can see that they call these unstoppable applications. I have a broken slide. No, I just have a blank slide. I don't know what happened there. All right, sometimes the Ethereum folks get a little bit, it seems like a little bit extreme almost, or a little bit like, I don't know. There are interesting implications. If you can have an app that runs that's incorruptible, that's kind of unstoppable, right? Like now it's out there on the network. It's like BitTorrent, where if people are getting value out of the network, they're going to keep contributing. So these applications will be able to keep running. So you can have a democratic autonomous organization, which is a mouthful. But it would be a little bit like building Uber the app without needing Uber the company. You don't need a mediator to make sure that everyone's doing what they're supposed to. You don't need servers on the other side of the backbone of the internet making sure everyone's doing what they're supposed to. Everyone in the network can verify that that's working correctly. You could have Airbnb the app without Airbnb the company. So this is a really interesting idea. And then you can see that they also say you can build your own country with an unchangeable constitution or a better delegative democracy. Some of it seems a little bit like, you know, very blue sky. They picked an appropriate background for this. All right, that is my crash course in offline first and the distributed web. This talk is amazing. IPFS and the permanent web. I highly recommend that one. It is worth the hour and 9 minutes. Other good resources for all these things, offlinefirst.org, BigChainDB, Ethereum.org. Those are all right. I will wait for people to take pictures. I'll try to send out the slides on the meetup. And Jolie is also going to post video of this. And we will share the video link and the slides on the meetup page. All right, so here's my little summary. Hours-long latencies are the new normal. Let's design for them. Offline First already makes this possible for kind of single user workflows. And the distributed web is emerging now and brings fully communicative apps to any edge of the network. Questions? Comments? Thanks. We have a microphone in a box to throw to you if you have a question. It's really fun.
So the obvious question is, who's going to pay for distributed, servers? Who's going to pay to keep all this data somewhere? So the Ethereum model is that you pay with Ether, but do you have other ideas about that are less like that?
Yes, so IPFS is thinking about that also, and along with the IPFS protocol that they're building a separate protocol called Filecoin. And it's similar to Bitcoin, where if you got into Bitcoin in the early days and you were helping verify that transactions were happening correctly, you ended up getting a lot of Bitcoin because they were rewarding people for verifying those transactions. So there's incentive to get into it early, And then you could also have people, right? Like you could set up your own like servers in your apartment, and you would get, and people that want to put something out onto the network could pay a couple Filecoin and say like, please store this for me, please back this up for me, and incentivize you to run your own little server farm. So that could actually be like a business model in a web where IPFS actually works out. You could go around the world and make servers at different edge locations and get paid for it.
I think the obvious question is malware. Sounds like a great platform to build malware on.
Ethereum specifically?
Sure.
I wonder about that too, yeah. So with Ethereum, you can have these unstoppable applications, right? And the article earlier that I showed, the one that was talking about BitTorrent, it's from this article called The Rise of the World Computer. And so it's kind of like, right, you have this distributed mesh where they're all running these smart contracts and verifying that they're running correctly. Presumably there's some transparency into that, right? Like you can see what this contract is doing and you choose to be part of it, and you would be able to avoid, but yeah, I think there's serious thought that has to be put into those kinds of considerations, right? Like if someone builds a smart contract that is somehow malicious, and now that's always going to run because it's out on the network, it's kind of like the problem that I said with IPFS, where like if you have trolling or bullying or all those kinds of things, right? Like all of the awful stuff that shows up on the internet.
It's permanent.
It's permanent, right, right. Like that's good, but it's also problematic. Like it's good for most cases and very problematic for the bad cases. I agree.
It's not permanent because if you remember, Ethereum did do a hard fork earlier this summer on the Ethereum network where there was a problem with one of the smart contracts, and they reversed the transaction, and the choice for the Bitcoin miners were either to accept the hard fork or to not, or to just entirely remove themselves from the Ethereum DAO, which is what they call the currency or whatever for the Ethereum network. And that, yeah.
So was there you said there was a problem with a smart contract. Was it like a malicious smart contract? Or there was a bug in it and they were like, this is terrible, we have to undo this?
So basically there was a bug in the smart contract that allowed someone to transfer 12 million ether to a single person. And there was a number of discussions on should we fork it or should we not fork it? And ultimately they did fork it, where they reversed all the transactions on the...
So they had to get everyone that was in the network to agree to go on that forked version.
No, they didn't get everybody to
All
agree,
right.
but they...
That's why it forked. I remember reading a thing about 10 days ago that someone had published a tool for editing blockchains. And then they said, well, can they edit Bitcoin? They said, well, everybody would know if you did, but nevertheless, there is a tool so that you can, it isn't necessarily permanent because a blockchain can be edited.
I don't know about that. I will have to look into that.
I'll put the link on
From what I understand about blockchain is you basically have to control 51% of the computers in the network if you want to cheat. If you want to spend money twice, you have to be able to like control all of the computing power and make it look in this public ledger like you actually had that money. So I don't know about editing the blockchain. That's news to me.
Could you give us just examples of your imagined of how people might use this as an app, a realistic example of an app?
Right. So I think you could build almost any app that exists now on these emerging platforms. You have assets. So already with IPFS, you can do simple, like that Conference Explorer website, right? Like that would work because all it needs is a JSON document, HTML, and JavaScript. all of those can be served over IPFS. So simple apps can already exist on IPFS. If you want to back up the data, right? If you want to have your favorites show up on your phone and on your computer, then you have to use something like BigChainDB to store data.
Wikipedia, for example.
Wikipedia is a great example, yeah. Wikipedia, I think Wikipedia seems like it might be able to live entirely in IPFS, right? It's a bunch of documents. They all have a version history. That's kind of how IPFS works already. I'm not sure you would even need the other technologies that I mentioned, Ethereum or BigChain, in order to build something like Wikipedia. If you wanted to have, so some apps that people have already built on Ethereum are like a Kickstarter without the Kickstarter company, right? So you can say, this is my idea. If you think it's cool, send me some Ether, or like pledge some Ether. And then I will have to deliver, and it's run by this smart contract, right? So I actually have to deliver what I say I'm going to deliver. I'm not sure how that's determined in a way that can be verified by a robot, but people have already built this app. I haven't had a chance to look into it yet. And once I verify that, yes, I actually did build this product that I said I was going to build, then everyone actually then I get all of the money that people pledged.
I suppose you could also do a sort of delayed fire chat.
You could also do a delayed fire chat. What is fire chat?
Fire chat is what they used in the Hong Kong protests. There was a chat thing that worked without having a central server.
Okay. Yes. Yeah, you could definitely have people are also working on fully distributed Slack, essentially. So we here would all be able to communicate device to device, even if the internet connection is cut off to this building.
So companies build software to be successful, and they're kind of addicted to being connected to their users. And where you might think, and it might be right, that it is better if it's offline occasionally, and then that's not what you want to do. You want to be offline all the time, but then the company loses touch with its users. So it's hard to invest. It's hard to justify investing in a tool like that, because you lose the data and analytics, and everyone's driven by instant analytics, which is the other side of being instantly connected. How do you think about that?
This is. I'm glad you brought this up. So there's also with IPFS, the creator of IPFS likes to talk about how with IPFS you are more in control of all of the data that you put in the network. So you can actually encrypt it and then only give people with certain keys access to unencrypt it, right? Which means no company has access to it. So it's more like Signal than WhatsApp, right? If you're familiar with Signal, it is full an open source version of WhatsApp essentially. That's full end-to-end encrypted, but Facebook doesn't use it to advertise to you. So yeah, it's very good for users, but there's definitely the way the business model of the web works right now. A lot of companies would not be able to operate that way because it's kind of based on selling all of your information to advertisers and having this giant pipeline of user data flowing in. I think that it does open up the door to other kinds of companies, right? Or other kinds of, with the Uber without the company idea, you could even have robotic cars in the fleet, and you, with smart contracts, order a car, your car will show up, take you where you want to go. And I own the car, right? It's my car, so I've put it out there and now I make money off of it. But there's not a middleman, there's not an intermediary that's going to make money off of it. So it's an interesting, or maybe the person who created this specific version of the smart contract gets a tiny little cut. So they put the software out there, the smart contract exists and can send them their little cut. But if someone else wants to build similar software, they would be able to do that.
So at Citrusbyte, I'm kind of curious, in a place like Citrusbyte or any other sort of design shop, how are you able to use these ideas in that kind of environment? And
so far at Citrusbyte, I have not had a chance to use any of these ideas. These are just cool things that I heard about at that abstractions conference that I showed earlier. Offline first seems the most immediately available, right? Like Ethereum and IPFS seem really fun to work with. By the way, if IPFS works the way that it wants to work, they want to kind of become part of how the internet actually works. And so down the road, we might all be using IPFS without needing to learn anything new. But if you want to start experimenting with it now, you can. But certainly like the PouchDB stuff and the local storage and service workers, those give immediate benefits to users right now, and they're very easy to start implementing. You don't have to build whole new business models.
I was saying we're building an app for farmers in remote locations to run their farms and do a lot of data-driven farming, and that obviously is an offline-first kind of project. Citrusbyte.
So I am not working on that, but Citrusbyte apparently is.
You want a job? Yeah.
Maybe I'll work on that next.
So in a scenario where you have like a offline first app where you do have a central server, and then when they go offline, it's use local forage or however you want to persist it on the client, how do you handle reintegration? So someone that's been out there running in their own distributed environment for a long time, your central server has changed, you've changed the way you're storing data. How do you reintegrate these people who have been out of society or wherever for a while? How do you reintegrate them?
This
into
is
the
a
system?
great question, yeah. And this is something that the offline first movement kind of, right? So Hoodie was that kind of offline first framework that encourages, like, it's trying to make it easy to do this. And something they ran into whenever they started building it was like, oh, we have all of these new UI challenges, because if I'm like offline working for a while and then I get connectivity and it syncs up, if someone else like, you know, deleted broccoli from the grocery list and I changed it, I like fixed the spelling of it or something, what do I do with that? Now you have one person who modified it and another person who modified it differently. So there's like, you would have to offer some form of conflict resolution to the user, right? So that needs to be part of apps that work with this paradigm. Does that answer your question?
Yeah, and also like even from like a database perspective, like if you change your underlying model, you would also have to have some sort of resolution on that level as well, right?
Right. So if you change your schema, so the user updates a column that no longer even exists, kind of thing. I believe the reason that PouchDB is a thing is because CouchDB, I think, from my limited understanding, again, cosmic algae, from my limited understanding, it's more of a NoSQL database, right? So it doesn't have that strict schema, and I think it deals with changes to the like schema or to how you're representing the data in a straightforward way.
Thanks.
Mm-hmm. Back of the room.
So if you're looking to build something between offline first and IPFS, there's two pieces of technologies. WebRTC, you need to be connected to a central server to do the turn, but once you're connected to another person, you can actually send data peer-to-peer.
WebRTC
WebRTC.
lets you communicate peer-to-peer after, right, yes.
turn.
This is like video chat apps use
Yes.
WebRTC,
You
right?
don't
So
have to
like
use video with it. It is you can send a data stream by
you can
itself.
send a data stream, so you can send
Yes.
any kind of data over
Correct.
WebRTC. Right, but that's what
But you needed to be connected to a server for the initial turn to
right.
connect.
There's a video chat service that is built on that where it's completely client to client. There are a couple.
I don't know about that one. The other piece of technology.
Appear.in. Yeah, that might be it.
Mozilla has a tech on kind of in development called FlyWeb, which allows individual web pages to act as web servers to local discover zero config, local discovery of web pages, and then off like non-IP HTTP over like Bluetooth and stuff like that. HTTP over protocols that aren't IP, and that's the FlyWeb project from Mozilla.
What's that called? The what?
FlyWeb.
Lightweb?
Fly like
Flyweb. That's similar to other things that Jolie was telling me about before this presentation. It sounds similar too. Like there are these new technologies for like all of our smart devices that are very low powered to communicate and send data over like Bluetooth or
wire and stuff like that.
low frequency infrared or whatever, right? I forget what the other one was. Low frequency radio.
I was telling him about the Things Network.
The Things Network, yes.
Laura, can I ask, what is the name of the guy who invented IPFS?
I believe it is Juan Bennett. I hope I got that right. It was in that video that I linked at the end, actually. So let me,
We
yeah,
can
I have a
post
lot of
it.
slides.
We'll yeah.
Look at it go.
We'll add it to the slide.
There you go. Oh, it doesn't say his name in it, though. All right, well, I guess that's all.
Thank you so much. That was really great.